Hello class, so now I'm going to start doing some specific problems, specifically the one I'm going to focus on right now. We'll see how many more I can get through, is this one. So I've alluded to these things. We haven't really done any major calculations on them though that I haven't walked you through. And what this is 2D kinematics. For some reason my screen is squeaking, if you can hear that. Anyway, so the idea is just like forces. Remember, in forces we could have, F in, but we could also have some F pull, maybe some friction, and of course gravity. Sorry, that's a little off. I'm a little off today. Kinematics can do the same thing. So you have to think that we have two equations. One in the y direction and one in the x direction. So kinematically speaking, we have this where it's going 18 meters per second this way, and then in the beginning there's no downward velocity, and then at the end there's of course acceleration due to gravity. So we do have acceleration due to gravity. Alright, so you need the two equations to find the range, because we don't know how long it's going to take to go a certain amount of distance. However, if our acceleration is due to gravity, we know how long it's going to take to fall. That would be in the y direction. So in the y direction, we know that its initial position is at 13.2 meters. We know when it's over, it is on the ground. We know that the initial velocity, and we're not shooting our cannon up or down, we're shooting it horizontally. Our initial velocity is 0. And we know that acceleration is equal to negative 9.8 meters per second squared, because that's gravity. What we need to know is the time. So plug this into your kinematics equation, which is plus 0t, we can cross that out, plus negative 9.8, almost forgot the 1/2 in there, which is why you should always write your equations first, not second. So 1/2 at squared, so this 1/2 goes in here, so we have 0 equals negative 13.2 minus 4.9, which is 1/2 of 9.8, and this t squared sticks around. Move this over, it becomes positive. Excuse me, negative. I prematurely called that negative 13 because I knew it was going to be negative. Sorry. Anyway, this is positive 13 because it's above the ground. Like I stated here, I switched it when I moved it down for whatever reason. I get negative 4.9 t squared divided by 4.9. That gets you 2.69 is equal to t squared. Square root it, and then t is equal to 1.64. This is our y equation. Yes, these problems are long, so if you are trying it on the test and you can't figure it out, these would be the ones to skip because they are quite long when you have to do both sides. Then the next one is our x. There is no acceleration in the x direction. Remember, Newton's first law, object in motion stays in motion. So there's no net force, there's no acceleration. So it would just be x plus x naught v naught t plus 1/2 a t squared. There's no acceleration, so that's 0, which turns this whole thing to 0. Then, as far as we're concerned, this is called 0, this is called we don't know yet, so this goes to 0, so it's just x is equal to our v naught, which is 18 meters per second in the problem, in case you couldn't tell where I found that. And we now know the time. So multiply these together, and you would get 29.5 meters. And that would be your final answer, the total range. Hopefully that helped you. That was a long problem, and I will be moving on. Alright, so in case you're wondering, I'm going to do this one right now, because this is the most difficult one on this page. So the idea behind this is we're at an angle, so this is a completely angled problem, so your free body diagram would look something like our force of tension this way. This is our horizontal plane, so normal force must be this way. And we have to have gravity. I'm going to draw gravity in a different color here, which is always straight down, which is not terribly helpful for us. So what we need to do is break gravity into different sections. Well, that, or we could do the force of the tension. And actually, no, we couldn't. You have to break gravity up. So we want to know the force of tension. To know the force of tension when everything's equal, we have to figure out what part of our force of gravity is going, we'll do this one this way, is going in the x direction. Well, so we need to do that, we need to know the angle. So this requires a little bit of angle knowledge. So we know this is 25 degrees here. If that is 25, that means that, and obviously this is 90. If that's 25, that's 90. This has to add up to a total of 180, so you have to do some angle work on that one. So it would be this angle right here is 25 degrees. And we want to know the x, which is the opposite. So if we want to do opposite, that would be sine of 25 is our opposite. And it's multiplied times our hypotenuse, which is gravity. The weight from our gravity is 15 newtons. So it'd be 15 times sine of 25 gives us 6.3. So there's not a lot of math to plug into your calculator, but you really got to know your angles for this. Again, hopefully this is helpful. Alright, so this problem, it's actually one down. I accidentally erased all of it. But as the ball rolls down the hill, that should have been will it experience an increased momentum? Hopefully you know when a ball rolls down the hill, it does go faster, and since momentum is equal to this, if velocity goes up, then your momentum will go up. So, alright, and then what force causes it to increase momentum? Well, why the heck is it rolling down the hill in the first place? And that would, of course, be the force of gravity. Hopefully that was rather self-explanatory. Alright, the equation for conservation of energy is energy total is equal to the potential energy plus the kinetic energy. So when we're talking about a situation in which energy is conserved, it means that this will stay the same no matter what. So even as energy changes, it will totally stay conserved. So anytime we have a frictionless problem, or we can think of an elastic collision. Anytime something bounces off perfectly. Fortunately, it's not a perfect world, so there's a lot of them where it's not conserved. This, remember, is called an inelastic collision. And things could stick together. Or you can think of them as not bounce off. Now I'm going to clear it all. Alright, this one right here is a little more nuanced. Which direction is the net force on the ball? Remember, anytime we're talking about circular motion, your force must be going towards the center. Anytime there's circular motion, your force is towards the center. So for this one, it's towards the center. As for will the speed change, well, remember we talked about conservation of momentum? Notice they said there's no friction, so essentially the ball is going to bounce off perfectly, which means energy total in the beginning is equal to the energy total at the end, which is important. So if it's moving, there's really no potential energy. That means all the energy is this, and it has to be equal to all of its energy, and the mass doesn't change when half doesn't change, therefore these do have to be equal. So your speed has to be equal because it's not losing energy through friction, so its speed has to be the same at the end to maintain the same amount of energy. I'm not going to do that one. I guess we could do this one really quick. So assuming there's no friction, because normally friction is your main one keeping you in. You can think of this by drawing. It sort of draws the lines for you. But gravity pulls you this way, which is not going to help you not slide off. It's the old, because this is on a ramp. So to stay turning, we need an inward force. So, and the normal force, because we're on a slant, remember, it's always perpendicular. So this is our normal force. So part of it counteracts gravity, and part of it provides our inward force. So normal force, so when it's slippery, you need a banked curve for the normal force. This is why on flat surfaces, you don't turn as well, because normal force does not help you. And the only way to keep it going inward is you need some force of your friction. Otherwise, your car will not go inward. Your car would slide off on a flat surface on ice. If it's on ice and it's curved, you got a little more leeway because normal force will help you. And for all those not using audio, you should definitely listen to this because I'm not writing everything down. Anyway, hopefully they saw that. Otherwise, whatever. This one, there's actually no math to it. It's Newton's first law. Object in motion stays in motion. So your original horizontal velocity equals 20. Object stays in motion. it will still be 20. There's nothing to slow it down, so its horizontal velocity will be the same. Vertical velocity, because of gravity, absolutely changing. Horizontal is not going to change. Alright, this one, mostly the main thing you have to know is, is the formula. I keep writing it bad. Where it's m delta v equals f delta t, where your initial velocity is 0, and we want to know the final velocity, so remember it's final minus initial. But this is 0, so delta v is essentially just your v final, which is what you want to know. So this is your unknown, this is right here, this is your, and this is your time. I think you can plug and chug that without me. And you know the answer, so you know if you're on the previous video. No, this one right here, you just have to do this one twice. Where you can just leave this in or ignore it, it will not change your answer. So don't worry about it, because they're going around the same circle, doesn't matter. So you can leave or ignore it and do this equation twice. Next one. This is just a triangle problem. Horizontal component's 10. Therefore, it's an a squared plus b squared equals c squared kind of problem. Oops, meant to drag this, not the line. This one is a little, it sounds complicated, it's not. What they want you to do is basically make the triangles here. These are the same triangle because they both are at 60 degrees. And all they want you to do is to write it out. So it'd be the sine of 60. So that's, if this is our angle, this is sine right here. Opposite over hypotenuse. Guys, if you do not yet know what SOHCAHTOA is, I rarely tell you to memorize this, but memorize this. If you do not already have it memorized. Memorize it and then get ready to write it on your paper the moment you get it. On your scratch piece of paper. So, for the y, it'd be sine 60 is equal to opposite, which is, you know, essentially my y, over the hypotenuse, which is t2. Solve for y, y is equal to sine 60 t2. And since t1 is the same kind of triangle, it'd also be y is equal to sine 60 over t1. X is just the opposite with cosine, so it'd be cosine 60 t1. Let's do y2, y1, x1, x2. I know I did them out of order, but I'm trying to do as many as possible, so I have to go as quick as possible without sacrificing too much. So this is the vertical, and this is your horizontal. This one is a constant speed problem, so we don't even care what it's going, we just know it has to be at 20 going backwards. And net force, hopefully you know this by now. All I'd have to do is subtract my forces, so it'd be 25. Well, it's technically right minus left. So it would be -5. Why did I write 25? -5 newtons going to the left, essentially. This one is a large conservation and momentum problem. So really, remember I said make a really good before and after. So this has both a 20 gram. Notice this is also in kilograms, so you would have to convert this one to make sure they're on the same page. So, and we know that its velocity here is 249. However, then, meters per second, we know that this has to be equal to the new block. And we want to know what the final velocity is. Remember, you have to add the bullet and the block because they are together. So it'd be 0.5 plus 0.02 is equal to 0.52 kilograms. So it'd be M1 V1 equal to M2 V2. We're trying to find this velocity. So we divide by this on both sides. So then it just becomes a plug and chug problem. Equal 9.58 meters per second. This one, there's two ways you could do it. One is the energy way, which, since we haven't done energy yet, I think would be more difficult. Two is the kinematics way, which you should have a formula, which actually this made the formula for this. The formula for this is V2 is equal to V naught squared plus 2a x minus x initial, final position minus initial position. And remember, it's falling, so when you're falling, the acceleration is a negative 9.8. So it's a plug and chug here, so this, your initial velocity it's falling is 0. Its final position is going to be 0, because that's ground, hits the ground. Its initial position is 9 meters above, and this is our question mark, so you plug in to find it. The energy one is the idea that it has some energy before, and that's equal to the energy after. In the beginning, it only has potential energy. And when it's falling, right before it hits the ground, like you're pretty much thinking it's less than basically the smallest unit of measurement you could think of close to the ground, so that at the end it would be only kinetic energy, which is this equation. So now it's only kinetic. So we know these two things must be equal to each other. If you have two things on both sides, if you divide it to get rid of it, you will get rid of both. So we just have GH is equal to 1/2 V2. We know G is the acceleration due to gravity. We know H is essentially our 9. Let me rewrite this to make it more obvious. So our G is 9.8. Our H is 9. We can move this 2 over, and then it's equal to V squared. Hopefully you can see that, oh wait, this is V squared. Our V naught 0. we're multiplying 2 times 9.8, it is negative in this case, and 0 minus 9. Hopefully you are seeing the very strong similarities here, which is why they get the same answer. This equation came from conservation of energy. After this, it's plug all this in, square root it. Your numbers here would then give you 13.3 meters per second. Alright, so on this one, hopefully, if by now you have not figured out that the answer to all of these, the direction would take, they're always horizontal, or they're always at a right angle to your circle. There's really not a lot I can explain that. Sorry, I spelled sketch wrong. I'm looking at that now. This is just the idea that FG is equal to MG. You know what G is. You know what this is. You can solve for this. And this one right here, that was a convenient underline, is another conservation of energy, or I'm sorry, conservation of momentum. You know how heavy you are. You don't know how fast you're gonna go. Don't know this. You know how heavy your backpack is. And you know how fast it's going. Therefore, you can figure out how fast you're going. It's roughly 1 if you round it. Alright, so in case, again, use audio, because I'm going to talk most of this. Xandra runs with her dog. If she has a massive 68 kilograms, her dog has a massive 20 kilograms. They both are running at the same speed. Who is allergic to kinetic energy? I mean, for me, obviously, I've done physics for quite some time. It's obviously Xandra. Because your formula for this is 1/2 mv squared. This won't change for either of them. They're running, unless your dog is running away from you, their speed is the same. Oh, it actually says it. Their speed is the same. The only thing that could change is their mass, so more mass equals less speed, less mass equals more speed. If you write this as the only part on there, that does not have any credit. If you're listening to what I'm saying, rewrite the things I'm saying, that would be credit. What's the momentum of a water ball sitting there? Very obviously 0. It ain't moving. It ain't doing nothing. It has no momentum. Alright, this one down here, remember this is your yellow car here. This again is a much harder conservation of momentum problem. It's saying that these two are going to be equal to these two right here. So you're going to in fact have mass 1 of your, I'm assuming that's a black car, mass 1 of your black car times velocity 1 of your black car plus mass 1 of your yellow car times the velocity 1 of your yellow car is equal to the mass 2 of your black car times the velocity 2 of your black car, hopefully you're getting an idea, times the mass 2 of your yellow car times velocity 2 of your yellow car. It's a long math problem, but there's not actually a lot of work to be done here, because it's mostly numbers they all give you. Plus, I'm running out of space here. So this is your black car. Then your yellow car, you know, okay, it's 400, it's going 2 meters per second. Then we go back to our black car. It hasn't changed mass, unsurprisingly. It has, however, changed how fast it's going. That's a 3. It's hard for me to read on this. I had to go look at the paper. And we want to know, and we know this car hasn't changed, but we have no idea what this is. So now it's just kind of a big math problem. It's all addition and for the most part. So this is 800, it's 250, and that's equal to 1,500 plus this 400v squared. This is 330 equals 150 plus 400v squared. Subtract from both sides. And hopefully from this point you can solve it. So yeah, this is just a longer conservation of momentum. We haven't done these, but it's the same basic principle. There's just more things to write, really. So basically, it's really like the black car hit the yellow car, and then the black car is still moving, but it's not going as fast because it transferred a lot of momentum to the yellow car, so the yellow car is going faster. That's by and large all it is this. Again, I'll talk about the last one. I'm not going to really draw much because it's going to be hard to draw on here. The force is always towards the center. Hopefully if you've been watching any of these videos, you've gotten this point. Velocity is always tangent or along the circle. Or you can think of it follows the straight line of the circle. So anytime you have a circle, this is that straight line on the circle. This is this straight line on the circle. If you let it go at any of those points, this is the line it will go. Alright, hopefully you're understanding this and working towards it. Remember, make sure you understand it. Write down full answers for full credit. So write full answers and show work for credit. So you cannot just write the answers because I've given you all the answers. So you must show work for credit. Hopefully this is helpful. I'll see you guys on Monday. Good luck studying for all of your finals.